The purpose of a heat pump is to absorb low-grade heat in one place where it is plentiful, then to transport, concentrate and release it in another location where it can be used for space or water heating. The ground absorbs low-grade solar energy by means of direct sunlight and rain. This gives the ground a year-round temperature of around 8 to 12 degrees Celsius. But how can this low-grade heat be used to heat an entire building? A cold water antifreeze mix is pumped through the ground within a series of energy-absorbing pipes known as ground arrays. As heat naturally flows from warmer to cooler places, the antifreeze mix circulating around the array is constantly warmed by the ground's low-grade heat. Having increased in temperature, the antifreeze mixture is fed into a heat exchanger called the evaporator. Within the secondary sealed side of the evaporator heat exchanger is a refrigerant which acts as a heat transfer fluid. When the water antifreeze mixture enters the evaporator, the energy absorbed from the ground is transferred into the refrigerant, which begins to boil and turn into a gas. The refrigerant never physically mixes with the water antifreeze mixture. They are separated like sandwich layers by the plates of the heat exchanger, which permits the heat transfer. This gas is then fed into a compressor. The pressure of the refrigerant gas is increased in the compressor, which makes the gas temperature rise. The hot refrigerant gas then flows into a second heat exchanger called a condenser, which features an identical set of heat transfer plates. The condenser delivers water hot enough to serve the space heating system and, if required, the properties hot water needs. Having transferred its heat, the refrigerant gas reverts to a liquid. This liquid is then passed through an expansion valve at the end of the cycle to reduce its pressure and temperature, ready to commence the cycle all over again. Low-grade heat stored in the ground has been upgraded by the refrigeration process to deliver hot water. For each kilowatt consumed by the heat pump, 4 kilowatts of energy is generated, effectively meaning the cost per kilowatt hour is quartered.